Are we live? I think we're live. I should probably change my picture frame. All right, so we're going to do something different today instead of Minecraft. Um, I've been tasked with building a mobile parking system, and so what that means is when you go into a car park, you have to pay to get in. So normally there would be a Boomgate, and then there would be a payment system. So in Australia, you would swipe a credit card or a debit card at the terminal. The Boomgate would open. You would go in, park, and you'd be there for a certain period of time. And then you would leave. You'd tap your card. It would remember that you tapped that specific card, and then it would open the Boomgate and it would charge your card. So what's happened is why I'm involved is some lightning struck the parking boom gate and knocked it out. And so it was basically down for a whole weekend, a busy weekend. So they had to use a manual parking attendants. And the problem with that is they don't know how long people have been there. So they just sort of have to either guess or just choose a flat rate. And if they choose a flat rate, usually it means they will lose some amount of money. So I said to them, hey, I can build a mobile parking boom gate. And to track which cars are coming in and out, we can use some sort of computer with a camera, with some sort of computer that has a camera and license plate recognition. And what it can do is it can just see the car that comes in. As it comes in, it'll register in the system as this car has come in. And then when they leave, it'll register that they're trying to leave. And there still needs to be a parking attendant, but the parking attendant can have a look on their little tablet and see how long they've been there and then work out, or it'll just tell them how much to charge this person, and then they'll use a little square reader and charge that person for the parking. So I've done the software side for the most part. So that's already done. We can take a look at it later. But I want to test it in sort of the semi-real world. And the semi-real world to me is some electronics. We'll put something together. And so from the electronic side of things, you know what? Let me see if I can get a camera set up and I can do a little sketch and sort of show you my idea. Give me one sec. I need Allen key. All right. I am in my tool shed. I need Allen keys. This might do the job. So I've got Allen keys, or maybe you call them hex keys. Let's see. And the reason I need that is because I have an iPad on a stand, but it's locked in. You need an Allen key to get into it. So what I want to do is just loosen this up and then have the iPad camera pointing down so we can have a look at what I am going to draw. Now you can't see what I'm doing right now. I'm just adjusting it so that it is pointing down. Tight. All right, cool. So we have an iPad pointing down. Let's turn it on. Now, do front camera. Connect. No, not front camera. That was the wrong one. Back camera. Connect. Okay, we've got the back camera. And we need to connect that to Streamlabs. Let's see. How do I normally do this? I think add a source, add a, it's an image source, not image source. I'll get there, give me one, just be patient. It's a browser source. Browser source there, add, and fill fit to screen. Why is it long ways? What's the resolution of an iPad? 1920 1080. Hit the screen. Yeah, that'll do. That'll do. All right, so let's get the sketchbook out. We'll make some space. All right. That's the right orientation. Is it? No, it's upside down. How do I do this? Maybe that. That is still upside down. We can, maybe we'll live with it. Oh, you know what I have to do? I've got to flip this around the other way. So let's do that. So that will make people dizzy. Okay, so camera is here. All right, so let me just orientate that a bit. All right, so there's my working space. What I can see and what you can see is very different. Okay, so that's the top and that's the bottom. All right, so I'll try and work within this space. Okay, so let's have a think about what a parking system is. You know what, let's hide my head. You don't need to see me in this scenario. Okay. All right, so where's my finger? All right, technical issues, we'll sort this out. All right. So a car park, right. So let's say this is a car park. We'll say this is an entry. This is an exit. Sorry about my handwriting. Car will come in here. In our system, we want a camera to take a photo. So that's a camera. Doesn't look like one. Let's just, you know what? Let's say camera. Okay, so we have a camera. It will take a license plate ALPR, license plate recognition of that thing. And so at that point, we'll call that event a check-in. So check-in. Then they will park some in here. So they'll move along. They'll move along. They will park. At some period of time, they will exit here. At this point, we will take another photo, like so. And again, that will be ALPR. And as an event, that will register as a checkout. And so the time in between is our duration. So we'll say duration. And we need to charge a certain amount. And so what that certain amount is, at least in the car park that we're looking at, it's a tiered system. So the way it works is if you were there for 30 minutes or less, 30 minutes or less, it costs you $0.00 or free. After that, I believe it is after 30 minutes is like I don't know, it's a flat rate. It's something like, let's just say $6.50. And then after a certain period of time, let's say, I don't remember, but let's just say it's 4 hours. So if it's more than 4 hours, then you get charged just a daily rate. So I don't remember what that value is, but let's just say it's $10. And so that's how that system works. So that's the basics of the parking system. And so what we want to do now is work out, well, what is the hardware we need for this parking system to work. Right, so what do we need? We need a camera. So first one is we need a camera, or we need something with a camera. There are some cameras that are computers and cameras built in. There are computers that have cameras built in. The downside of a camera with a computer built in is it's expensive, and I don't have one. So that's our first hurdle. The other one, if we get a computer and a separate camera, both those components you can get quite cheap. You could get a Raspberry Pi, you get a little webcam, and you've got a camera and a computer all at one. Raspberry Pis aren't that cheap these days. When we talk about a parking system, they're pretty cheap. These parking systems, fixed ones, can cost between $10,000 and $20,000 per entry point. So per entry point, that's how much they could cost. A whole system altogether, I had a look at a car park in the Glenelg Council that the council paid for. They paid $500,000 for, I assume, is hardware plus a parking management system and plus ongoing maintenance for that. But we just want to build a prototype. We just want to build a working prototype with as little cost as possible. Maybe it needs to look a little bit semi-professional if we want to do a demo on site. If we're not doing a demo on site, it doesn't matter. I think for now, what I want to do is build a scale model with a working Boomgate. So let's talk about what we need. So we need a camera, and I've just said we want a working Boomgate. And what else do we want? We need a computer. There's some things we need from that computer. It needs to be able to connect to the internet. In my case, I do have a Starlink Roam, also known as a Starlink Mini. And so as long as our computer has Wi-Fi, we will have internet access. The computer we choose depends on what we want to do. So we know we want to do ALPR, so license plate recognition. And so we can do that on device. And so if we have a powerful enough computer, we can do it on device. If we don't have a powerful computer, so we have a terrible computer, what we can do is what I've done is written some software that does license plate recognition in the cloud. And the way that would work is your camera, your computer would be triggered by some motion. It would see a car. It would take that photo, it would send it to the cloud, and it will say, hey, give me back a license plate for this photo. And so the heavy lifting is done in the cloud. It'll come back with a result with that license plate. But that's probably the cheapest way we can do it. Yeah, let's go with that. And so the reason we need Wi-Fi is to go to a cloud, ALPR service. All right, so camera, Boomgate, computer, Starlink, Roam. I'll just say Roam or Mini. The other thing is we need power. We need power for the whole thing. We don't want to be running off a generator. That's a bit noisy. We don't want to be running off a giant lithium battery. That's too expensive. Mini. The Starlink Roam, I do have a connector that will run it on a tool battery. So we'll say tool battery. And some of those limitations is that lasts about 4 hours. Now, if we have a parking attendant, they can swap that battery out. So we could potentially run for quite a long time, at least 24 hours if we have enough spare batteries. I believe in this case, the example that I'm looking at, there is PowerPoint, so I could connect to power. But for the sort of prototype that I want to make and I want to show people, I would want it to be mobile, so I'd want some sort of power bank. So in this case, let's call it a power bank. We'll put a pretty chunky power bank, maybe 10,000 milliamp hours. Hours, capital H, I don't know. Okay, what's next? Camera, so let's think about it. So we have our computer, which connects to a camera, which connects to the internet via a Starlink. That's a computer, that's a camera, and this computer will then also need to connect to a Boomgate. How are we going to build a Boomgate? We can probably connect to a servo motor. So let's put that on here, servo motor. And we'll just open it, close it. That's a servo. Yeah, I think that's it. We need wires, of course, maybe a breadboard. I prefer to wire things directly. I think breadboards just a bit messy. They're good to test connections, but that's about it. You wouldn't want to use it for a presentation. Have I forgotten anything? Let's think it through. So the computer, the software will trigger that. The camera will trigger motion, so we'll have to do in-software motion detection. That's pretty cheap, so that should be fine. We'll send that to the ALPR. If we angle the camera in a way that it only ever gets the license plate, we can avoid false positives, so like a vehicle from a distance coming up. Yeah, that'll work. And then, so by default, the Boomgate is down. ALPR will detect the car. We will get a confidence rating from the cloud service, which will tell us how confident it is that it detected the correct rego. If it's not confident, we can take another photo, so maybe a single retry. And then after that, we'll let the car through. And then do check-in. So on the way out, the same thing can happen. It could misread the license plate. So we will, since we have a person, we have a parking attendant that will be taking payments. They need to be able to see the cars that either are the same rego or similar in case that detection didn't match correctly. I think that's it. All right, so let's have a look at what we got. Let's do. So I have actually already thought about this. So what I've got here is a Raspberry Pi Zero. Now this is an old one. I do have a new one somewhere, Raspberry Pi 02. I know they're the same form factor, but I don't know if they have the same connections. So let's actually have a look. So the camera connector goes on the end here. Sorry, let me put that on screen. Sorry about the lighting. We'll live with it. Okay, so there's a camera here and there's a camera connector here. And I suspect everything is the same form factor. If it is, we might just swap out the Raspberry Pi 01 with the Raspberry Pi 02 because the 2 is faster. So what's the difference? The connectors look the same. It's got a heatsink here. That should be okay. We have header pins already soldered in. That might be an issue because this expects the header pins to be on the back if they come out. So we won't be able to use the 02, which means we're very limited on any sort of processing. We probably won't be able to do any in-device motion detection. So that's a good question as to what we will do. Let's have a think. If we're not doing motion detection, we could, since I made my own API license plate recognition service, I made a API as a service. It's not going to cost us much, if anything, to just constantly spam it with images. So we could just have this thing periodically taking photos and asking for a detection. And if it gets no detection, well then it doesn't do anything. Yeah, I think that'll work. We do have some alternatives. Let me just see if I can find them. I have this little guy, which is even less powerful than a even less powerful than a Raspberry Pi Zero. It's an ESP32 cam. So it has a camera. It's got that little red dot. It's just a plastic protector. If we go that route, it will still work. It's probably a lot easier as well. Programming for microcontrollers are actually quite simple, as long as you know C or C++. Because with the Raspberry Pi, we have to put a whole operating system on there. So you would put Raspbian on there, and then you've got to write your program. The benefit is your program can be whatever you want. It can be in JavaScript if you wanted to. You could write it in Rust. You could write it in C. You could write it in Python. I think Python goes really well with the built-in hardware. But then there's this thing, which is just C++. There'll be sample code out there for the camera, so that will work really easily. Oh, that's a hard decision, actually. I'm probably leaning more towards the ESP32. Just from a development point of view, it is a lot simpler. It is less flexible, but the camera quality is also terrible, which could impact our demo. But if there is enough light, so we test this during the day, the quality should be good enough to get a license plate. And it is smaller, so we could make a little miniature parking system, which would go well. Look, how about, let's go with the ESP32 for now. I don't want to use this one. These ones are a pain in the ass to program for without the attached programmer board. But I do have lots of these, and I do have one. It's in its bag still, but you can't see it. I'll open it up. Let's do an unboxing. What do we need? Scissors. So So let's see what we got. What's in there? Oh, we have a camera. We can't do an unboxing with this paper written everywhere. We have a camera. Let's see what else we've got. And then we've got the ESP32, and attached to it already is a programmer board. So we can take this apart, and so that's the programmer board. Very simple. It just allows us to connect with a mini USB. I think it's mini. Was it micro? I don't know. I get them mixed up all the time. So we have a programmer board, and we have an ESP32. So on here is, look, it's upside down. Okay, we have an ESP32S. It has Wi-Fi, has Bluetooth. Focus, fuck. Up the top here we've got an antenna. On the other side we have an SD card reader, which we won't use. And then right here we have a connector for our camera. So let's attach our camera. And if I can remember how to use this thing, I think you lift. Yep. And this thing goes in there somehow. I think you need smaller fingers than I have. I think that'll do. Then we close it. Yeah. It's got some adhesive here, so I think we can stick it down to there. And then when we're ready, we'll take the lens off. We don't need to take the lens protector off at this stage. And we'll put this back on the programmer board. There's actually no reason to take it off except for form factor. That's it. Oh, actually, you know what? I do have, if you have one of these without the programmer board, you can get one of these, which is a USB to TTL, and you wire up a bunch of pins from here to here, and then you can essentially do the same thing. But this thing, way more convenient. So we will stick with that. What else have we got? So that's our computer and camera all in one. So that simplifies things. And the next thing we need is, next thing we need is, what's our instructions say? We need a Boomgate, which we decided is a servo. So let's see if I can find a servo. So I've got a whole lot of electronics. Oh, box of servos. Okay, so box of servos. I don't know anything about these, but that should do the job. Let's have a look what this servo is. Can we see it on screen? Focus. An SG90, 9 grams. So we'll want to attach something to the end of that. Don't know what that is at this stage. And I don't have any little adapters. So these little things have little gears. Well, maybe they're not gears. They have little teeth that you can attach things to. So what do we got? Computer, camera, servo, computer. You know what? Let's tick it off our list. We have a camera. We have a computer. It has Wi-Fi. We have a cloud APR service, but it's running on my computer at the moment, not in the cloud. So we'll have to put that in the cloud. We need a power bank. Power bank. It's not 10,000 milliamps, but it should do the job. The problem with a lot of these power banks is they don't draw a lot of power. They just automatically shut off because they think nothing's connected. And I think that one is one of those, but let's just assume that we have a power bank. We have a servo motor. Starlink is in my car. Okay, so we have everything. Okay, so if we have everything, what do we do? Well, first thing is we need to work out how do we connect this servo to this ESP32, and even we should probably find out if it's an even good idea. Does this thing draw too much power and blow up this thing? We wouldn't want that. So let's do some research. So let me grab my computer. All right. I can turn my camera back on. All right. So what we're going to do is get a browser. Hang on 1 second. So we need a browser. Let's find a browser. Browser, where are you? How to add browser. Browser source, your web-based content. What's that? No, that's not what we want. We want a window capture. What have I done wrong? Window capture. Add new source. I'll call this Chrome browser. We are using Chrome. And Chrome. Excellent. That's a browser. Screen. Okay, cool. We have a browser. Doesn't need to be that big. Let's move it here. And that goes there. My head doesn't need to be that big. It's already huge. All right, cool. So what do we need? We have an ESP32 cam, and we have a SG90 servo. So we should write that down. So ESP32 cam, and we have a SG90 servo. All right, so we want to look up some information about these two devices. So for an ESP32, we want to look up the pinout board. So we don't want to see our Minecraft history. ESP32 cam pinout. And what we want to do is find one of these. And that looks like what we got. Let's see, power modules. So this is how we can power the thing. We might power the thing through the programmer board. So just plug it in via USB. That'll make it a bit easier. What has it got? A built-in LED. That's nice. We can use that to test our programming. What else? We want our pinouts. Where is the pinout? Pinouts. What do I need pinout? Where's the, I want a picture of a pinout. Pinout. Ah, here it is. Okay, so here's our pinout. Let's open that in a new tab. Let's make it a bit bigger. No, we can't make it bigger. That's it. So what have we got? We've got 5 volt, 3.3 volt. So USB is 5 volt. We have a ground, so we'll need a common ground. What else? A bunch of GPIO pins. Okay, cool. that's good enough for now. The next one would be the SG90 pinout. And that one looks good enough. So let's, well, it tells us how it's made up of. It's a battery, it's a motor and a control unit and a potentiometer. And so that potentiometer tells the computer, or gives us a reading of what position this servo is in. So we always know what position it is based on that potentiometer reading. And the way we're going to interact with it is using PWM, which is pulse width modulation. So basically, the smaller this active state is, the will represent a different angle. So a big giant one will be 180. So in between is 90. And here's an example of how it works. That is very helpful. Cool. Pinout, let's open that in a new tab. Okay, so there's our pinout. Nice and big. So it looks like we only have 3 pins to care about. So we've got a ground, we've got a power, which is our 5 volt. So we do need to connect this to the 5 volt of our ESP32. So let's make a note of which pin that is. Well, it is in fact the 5 volt. And we want to connect the 5 volt to the red wire. And then we want ground. And ground is brown. So we'll say ground is brown. And our last wire is the control. Control, which is yellow. And so we need to work out, where do we connect? We know we got 5 volts there, we got ground. We need to work out, well, which ones of these spare pins, these blue ones, can spit out PWMs. So how do we work that out? We can ask Google. So we'll say ESP32 CAM PWM pins. We can accept the AI result, but probably better that we read a website. So let's PWMs. Oh, no, I don't want to watch your ad. Okay, a comment. I guess we are reading the AI. All right, so for PWMs, it says we can use 2, 4, 12, 13, 14, 15, and 16, which are ideal for PWM. 14 and 15 are widely used for driving pan and tilt mechanisms. So let's have a look at where 14 and 15 are. 14 and 15 are on the same side, so we could make some connections pretty easy. So let's do 14 or 15 for our PWM. And so, all right, so that solves our wiring issue. Well, that says what our wiring is going to be. We still need to power the thing. So let me think what we can do. So I'm assuming I can plug into this USB thing and it'll give the whole thing power. If that's the case, I will just need a power cable for the battery, the USB cable, which I should have lots of all over the place. Now, the tricky thing with these USB mini cables is a lot of them don't carry data, or if they do carry data, they're unstable. And so your code that you upload to your device will often fail. But we will test that out now. So I do have a data cable, a USB cable right here. And where's the camera? Can't find the camera. Here. Yeah. So we'll plug that in. But you know what? I might have a USB cable tester. I do have a USB cable tester. No, it's not a mini, it's a micro. So I got my terminology wrong. All right, so what I've got here is a testing board. And with this testing board, we can find out, I don't know if you can see, but there's a whole bunch of little LEDs that tell us things. Let's just leave it at that. And so what do I need to power this thing? I need USB-C to power it in, power it up. So let's plug that in. Okay, and then what you do is you put your A in the A hole, and then you put your micro in the micro hole, and it lights up. So this cable only has power. So we can see VCC and ground are lit up, which means we can't program with that cable. So we need to find a better cable. Which is always tricky, finding a cable that has everything we need. What do we got? Just digging through my power cables at the moment. Got a container full of wires. I wonder if this is helpful. Does this provide enough extra light? Maybe. Looking for cables. Where would I find cables? Here we go. All right, I have got another cable to test. Let's see what this one does. What's it gonna be? Look at that, all lit up, all 4 lights. So that cable's going to be perfect for programming. So we can put this board away. Very handy, testing cables. I highly recommend it if you want to know where to get one. China. If you're in America, I'm sorry, it might be hard to get. But for Australians, easy. All right, so what do we need to do? We need to plug this into our programmer board here. And we need to plug this end into our computer. Okay, that's it. And what we want to do is sort of just make sure that we can program it. So how do we program it? We use a program called Arduino something. Arduino. Yeah, I don't remember. Arduino software. Is it a product? IDE? You know what? I wonder if we can program it on the cloud. Using a cloud IDE. That'd be handy. Go for it. Log me in. We'll call myself Nogbog. Do I want a newsletter? No. Do they want? No. No. Okay, let me just make this screen a little bit bigger. All right, ads. No, it's not an ad. Okay, what do we got? Well, let's do a test sketch. I'm assuming this cloud version can program stuff. We'll find out together. it's going to know about Arduinos, but is it going to know about ESP32s? What is this? Hang on. Select device. Arduino Cloud Agent not found. You need to download and install a plugin, the plugin, in order to upload sketches. Okay, sure. Go for it. Go for it. And we'll install that. Don't know what it does. I trust it. Okay, let's reload this page. All right, cool. It's an ESP32 CAN AI Thinker. That's the one. It knows. And so what have we got? It knows what we have. What does this do? Okay, we'll assume we've got all default settings. Go away. Okay, so I guess to start off with, let's just make sure our serial monitor is working. So we do, oh, this IDE doesn't have autocomplete. Well, this sounds like a job for AI then. ESP32 can blink sketch. Not a job for AI. Come on. We don't want to worry anything. We just want to make sure. We can turn the blinky light in. Right. There's a built-in LED that I want to test. There we go. So let's have a look. Well, we could just copy and paste. I would have liked to have gone through it line by line so we can talk about each thing and what it's doing. So this is assuming that LED pin 4 is the LED pin, which if we look at the breakout board, the pinout, sorry, it should tell us, but this doesn't. Built-in LED, here it is. Yep, it's connected to GPIO 33. Okay, so which one's 33? There is no 33. What are you talking about? Oh, it is just 30. Is that right? Let's read this. To blink the built-in LED on your AI Thinker, write your code to 4. The flash LED operates when the pin is set to high and off when it's set to low. Okay, sounds good. I will accept it. All right, so the first button here, this, can you see my mouse? No, you can't see my mouse. Well, I'm clicking this little verify tick. And that's going to check that my code will compile. It shouldn't take too long. Looks like it's good. And the next button next to it, which is an arrow, we'll upload it. I just realized it's really hard to read. Try and make it big. We can see down the bottom here, it is uploading. Get rid of my stupid head. Oh, there, head. Oh, what do we got? What's going on? Do we have blinking? We do, and it is very bright. Wow. Okay. Let's just turn that way because that is a very bright light. I think it might be it might be used as a flash. I wonder if that's probably why it's so bright. Wow. Okay. that is painfully bright. So let's comment these out and then upload that again. And hopefully when it starts uploading, usually it locks up the code. Look how bright this thing is. It's insane. Okay, cool. All right. Cool, that has stopped. So the next thing we want to do is we want to test this servo. So we need to connect this to this. It's going to be a little painful because we'll program it and then we have to put the pins in. We'll have to take this thing off. Oh, then we need power. That's not helpful. Well, you're going to have to work out how to get power to this thing. So let me just have a look what gadgets I have and see if there's anything we can use to power this thing. See, I've got a breadboard. That's an option. But with a breadboard, you still need to get power in somehow. What have we got? What have we got? I have one of these guys, which is a power supply. Could work. So we plug that into there. We'll put some wires into there. That should do the job. I wonder if I've got anything better though. Sometimes I just have loose USB cables that can do the job, but I haven't seen one in a long time, so I'm not sure it exists. What is this? Another unboxing. I think this is what we need. Let's open up this box. What have we got? It says a Key Studio Power Module Type-C Breadboard DIY Kit Electronics Accessories. Let's open it up. Ooh, what do we got? Magic plastic. Never been opened. So let's break the seal. Not that exciting. Doesn't make... all it does is make horrible plastic noises. Alright, so this one is the same as this one, except this one has this gross mini plug, and this one has this beautiful USB-C plug. Way better. So, and it's black too. Okay, so this will go on here. Well, hopefully it fits. I'd be sad if it didn't fit. Excellent, it does fit. And so if we get our USB-C cable and power this up, we have lights, which mean it says 5 volts and 3.3 volts. So our bottom side is 3.3 volts and our top side is 5 volts. We can connect 5 volts to this thing up the top, or 3.3 wherever the 3.3 is. It won't focus and you won't know, but it's there somewhere. Because we need to power the servo with 5 volts, we will power the ESP32 with 5 volts as well. I'm fairly certain it's not a good idea to power a servo directly from the controller board, but you know, I like to take risks. Alright, so we have gadgets. So we've worked out our power supply. We need some wires to wire things up. So let's have a look. All right, so we need some male pins to go into this one. And then if we take this thing off, we'll need some females into here. So we need male to female. And then to get power, we'll actually pin this into the breadboard, and then we'll pin this into the breadboard. So we'll need female to male, and we'll need 3 of them, and then we'll need male to male to pin into this. So 3 of those as well. Let's dig through my spare cables. All right, what did I say? Male to male, 3 of them, and the other one was male to female and 3 of them. All right, cool. So here's one I wired up earlier. Okay, so we've got our SG9 and we've got a little thingy on top, which is good. And what we've got is we've connected our, what do we call them? Males to the female. And so our purple is ground, and we are going to connect that to the 5-volt ground. Our red is grey, and we'll connect that to 5-volt grey. 5-volt there. This will just throw anywhere. You don't need to worry about it just yet. And then our ESP32 we will wire up after, but let's put some code on here that'll make it do something. And a popular thing to do is called a sweep. Oh. So let's go back to our browser. We'll make this a bit bigger. We'll move that over there a bit so you can see it. Okay, so what we're going to do is look for ESP2 sketch SG90 sweep, and hopefully we can just get some code to test with. We'll refeed the code before we upload it to see if it's good enough. Let's have a look what AI says. Sweeps the SG90 microserver back and forth between 0 and 180. Is it the blah blah blah? Cables. Yep, it says don't plug it directly into the ESP32 CAN. That's what I thought. Okay, we're not doing any pan into it, but this should still test it. Let's read through the code. So we are including a library called ESP32 Servo. I don't know if that's available, but if we press this, verify, it will tell us if it can't find that particular library. Hopefully it can. And let's go through this code one line at a time. Yep, it verifies the code. Okay, so it thinks the code is great. All right, let's have a look. Okay, so the gray things are comments. We don't care about those, so let's delete them. So what we've got here is we've got an instance of myServo, which is a servo class. And it's suggesting that we connect to pin 14, which we can. That's fine. We did identify 14 and 15 to be good pins. Let's see, there's a variable to store the servo positions. Looks good, it's an integer. And that's probably going to be between 0 and 180 degrees. All right, so first thing we do is attach the servo on a specific pin. Set the standard 50 Hertz servo. Don't know what that is, but if we have a look at the documentation for this, let's go GitHub. That's for the header file. Let's have a look at what documentation we've got. And we are looking for set period hertz. No documentation. Lovely. Okay. Let's have a look at the servo documentation. Okay, no documentation. Alright, what about the source code? That's the source code. This doesn't even exist. Okay, I think... Yeah, okay. Don't trust AI. It's just made up this function called set period hertz, which does not exist. So let's actually go to the Arduino's documentation, which is usually a fair bit better. And we want... So first we need to... Now this is the Arduino library. We don't want the Arduino library. This code is obsolete. It needs to be updated. Blah, blah, blah. Let's ask AI. Modern code ESP32 servo is old. Okay. I'm not sure Google AI is the right source. DroneBot Workshop. I reckon they're fairly reputable. They've got a video. Let's not watch the video. Show us some code. Oof, that's a lot of comments. They also have this. I wonder why. You know what? The code built, so it must be fine. Let's just go with it. See what happens. All right, so let's just assume this is a real thing, and yeah, attach the servo on a specific pin. Yep. Pulse widths for SG 90, 500 microseconds to 2400 microseconds. Okay, whatever. So attach is like, I don't know. I don't even know how to describe attach, but you do it a lot. Sweep. So basically what we're going to do is we're going to do a for loop from 0 to 180. We're going to increment 1 degree at a time. And what we're going to do is do a write of that integer, that is an integer, to the servo. So it'll start off with 0 and then be 1. And we're going to do 15 milliseconds. 15 millisecond delay. All right, cool. So good enough. Let's upload that. I do have to go in a second. Got to get my wife. But we should be able to we should have enough time to just test this. So we're going to upload this code. Let's remember that we need to be in pin 15. And I'm going to plug my wires here. I'm going to say gray is voltage and black is ground. And after that's uploaded, come on, get in there. And then we'll put this guy on the same row as that one. So these two white ones are connected because they're on the same row. Code is uploaded. So we can unplug this guy. All right, so we need to find pin 14. And we've got 5 volts. We don't want 5 volts, we want 3, 3, sorry. 3, 3 is this top one up here. That's ground. We want that goes on ground. Light gray goes on 3, 3. And our last little wire goes on pin 14. And the pins on here are not helpful. I think they say IO4. Oh, we made a noise. Okay, so it works. It's sweeping between 0 and 180 degrees. So So we successfully programmed this, and so this will be our Boomgate. So now we know that we can control our Boomgate with code. So cool. So that's probably going to be it for tonight. Tomorrow what we'll do is we'll get this camera working and see if we can do something useful with it. Okay, so thanks for watching. I will see you next time.